For the past century, education policy has swung back and forth in its view of the merits of cross-curricular teaching versus the discrete teaching of subjects in the primary school. This assignment will seek to discuss the benefits and drawbacks of each approach in relation to science and mathematics. It will first look at the various historical perspectives and the current policy stance, before discussing the theoretical benefits and drawbacks behind the teaching of science and mathematics alongside each other, and the views of educational writers and researchers. Finally, it will draw conclusions on whether discrete or cross-curricular approaches are better suited to the teaching of primary science and mathematics, whilst also providing comment on the place of ICT in enhancing children's learning. As succinctly put by Simon in 1980, primary education has been in a state of almost continuous transition throughout its short history, from the 1931 Haydow Report and the 1967 Plowden Report, before the curriculum became segmented into discrete subjects with the introduction of a national curriculum as part of the Education Reform Act of 1988, signalling an apparent move away from the cross-curricular approach by virtue of these new curriculum subheadings or subjects, which in themselves suggested a more compartmentalised delivery. This move, said Gillard in 2011, prevented teachers and schools from being curriculum innovators and demoted them to curriculum deliverers. So over the past 100 years, the view on how subjects are taught has changed as a result of policy guidelines. It's clear that trends have existed and indeed persist to exist in relation to what is deemed to be best pedagogical practice in terms of lesson structure. In terms of current policy, in 2003, Petheram noted that present guidelines do not always make the links between science and mathematics particularly clear. In 2008, an independent review of the primary curriculum was undertaken by Sir Jim Rose, which recommended a change from a subject-based curriculum to one that embraced 6 areas of learning, 2 of which were mathematical understanding and scientific and technological understanding, in order to promote cross-curricular studies. Following this, 2009's Cambridge Review proposed a curriculum based on 12 educational domains and 8 domains of inquiry, disposition, skill and knowledge. So we can see here an appetite to move away from discrete teaching towards cross-curricular delivery. If we look at the current national curriculum guidelines for science and mathematics, we can see that each subject area refers to and relates to the other closely. It is important to note at this point that whilst the curriculum is broken into subjects, there is no requirement for the subjects to be taught discretely. The organisation of the curriculum has allowed for increasing freedom of delivery. Alexander, Rose and Woodhead counter this assertion with the comment that whilst there is freedom to be had, discrete teaching will be necessary if every aspect of each subject's programme of study is to be covered. In terms of the theory behind whether science and mathematics should be taught together, Petheram sees the two as inextricably linked. Indeed, the links between the two subjects do appear to be undeniable, from units of measure and number to patterns and formulas. Davies and McGregor agree, and Dunn and Peacock describe this as the use of meaningful real-life context and genuine engagement to exploit children's natural curiosity and stimulate their imagination. Hurley adds to this assertion, suggesting that achievement in science tends to be higher with more curriculum integration, and Rutherford and Algren describe the benefits of teaching them together as science providing mathematics with interesting problems to investigate, and mathematics providing science with powerful tools to use in analysing them. An example of teaching science within mathematics comes from the Primary and Early Years magazine, who make the suggestion that a maths lesson with the objective of learning Venn and Carroll diagrams could be linked to a science topic on living things and their habitats. Children would use their learning from science to sort animals and objects into diagrams, and this would provide a context for the mathematics whilst consolidating the learning that had taken place in science. Let us turn to the perceived benefits of mathematics of its being taught alongside science. The Department for Education describes mathematics as a creative and highly interconnected discipline. However, it also details the importance of discretely taught numeracy. An example activity of the two being taught together would be children undertaking an investigation into the changes to water and ice as it is heated and cooled, using data loggers. This investigation would require children to observe the physical changes to the water, as well as the change in temperature. Whilst the children would be looking at a scientific concept, the observations regarding temperature would exercise the mathematical skills of measurement and graph work. So it seems that we should either be viewing mathematics as the language of science and therefore teaching the two in conjunction, or we should do this as well as teaching it as a discrete subject. Boss et al. Suggests that the two subjects are learned in the same way. Berlin and White add further to this argument, agreeing that the two subjects are so intertwined that they cannot be taught in isolation. The majority of research favours the idea that the two are supposedly best taught in conjunction. It seems that in theory at least, mathematics provides a language to science, and science provides a context for mathematics, themselves the two composite halves of a well-rounded education in either subject. So let us look at the merits of teaching mathematics and science as discrete subjects. Davies and McGregor suggest that English and mathematics are considered by some to be too important to be fully integrated into the cross-curricular mix. If so, then it would seem unlikely that mathematics and science could ever be truly integrated. Dunn and Peacock suggest that subject-based schemes can provide a valuable starting point for the non-specialist primary school teacher. Alexander et al. Point to evidence that much topic work has led to fragmentary and superficial teaching and learning. This is certainly a concern that the teaching of one subject may lose out in order to fit in with and be relevant to the other. We can see this preference, be it wholly or in part, for discrete teaching, as far back as with Haydow in 1931, who discussed the importance of an adequate amount of drill in reading, writing, and arithmetic. If we fast forward to 2010, we see assertions from the National College of Teaching and Leadership, who suggest that a connected curriculum need not and should not exclude discrete teaching. So we can see an obvious barrier to a cross-curricular approach in the importance placed on mathematics as a core subject, the suggestion being that the teaching of this dominant subject should not be compromised, therefore leading us to wonder whether mathematics could ever be fully integrated with another subject, in this case science. In terms of teaching science and mathematics in a cross-curricular fashion, as pointed out by Kerry in 2010, the Plowden Report of 1967 stressed that children's learning does not fit into subject categories. The skills and characteristics of cross-curricular learning complement the idea of a holistic development of the whole child that Davies and McGregor discussed in 2010, itself a reaction to a dissatisfaction with a traditional knowledge-based curriculum, where, as described by Dunn and Peacock, discrete bits of information were too often perceived to be located in and limited to subject areas. Rose, in his 2009 report, championed the ability of cross-curricular teaching to complement subject content. And Boss et al. Pointed to an increase in student motivation and positive attitudes, in turn leading to an increase in achievement in both mathematics and science. They also state that rather than the two subjects themselves being alike, it is the way in which they are learned that is alike. Dunn and Peacock describe ICT as a tool to enhance teaching and learning experiences. The Department for Education state that in both primary and secondary schools, teachers should use their judgment about when ICT tools should be used. In this digital age, it's important for us to discuss the relative merits and drawbacks, and the National College of Teaching and Leadership make the point that given the world we live in today, if ICT is not part of a child's learning environment, learning at school may appear less relevant or outmoded. Valentine et al. proffer that ICT motivates pupils and makes learning more enjoyable for them. It seems then that the use of ICT in the primary school, whilst being a national requirement, brings with it a plethora of potential benefits when used to support learning in the classroom, from resources and pupil enjoyment to relevance to today's children, themselves digital natives. However, its use must be used to support learning rather than dominating lessons for the sake of using technology. So it would appear overall that from a theoretical perspective, mathematics and science are natural partners. It would also appear that a cross-curricular approach, when executed thoughtfully, can benefit children's learning in both subjects. It is right for us to conclude, on the basis of the research, that there is a benefit to teaching the two subjects in a cross-curricular fashion, but that this does not mean that they should only be taught together. Instead, it is important that each is taught discretely when necessary in order to fulfil the requirements of the national curriculum. What we can also conclude from the research on this topic is that whilst on the face value the national curriculum would appear to be organised into subjects and would therefore seem to champion a discrete approach, the links between science and mathematics are obvious to see, and as such there is both room for and an ability to combine the subjects. Schools should not take the curriculum on face value in terms of how its pages are divided and ordered. They should instead inject creativity into the way that they make use of it when planning their curriculum delivery, making cross-curricular links when they are apparent, and spending time on planning for the integrated delivery of mathematics and science where appropriate in order to best teach content.